there was gonna be no way that I would finish both problems today. I mean, my plan was to do one of these problems yesterday, but since everybody was at the orchestra concert and never even told me about it, I only did one problem yesterday. And so this, out of the two problems left in the notes, this one felt more like one we've already done. I mean, it clearly doesn't look at all like the box problem from yesterday, but in terms of the types of derivative and solving and the layout of the number line, it's the same as the box problem. The setup is obviously not. Like this one, it didn't give us a ton of information. It said you have a can that holds 40 cubic inches of soda, which is an awful lot. I don't know where that number came from. Like, I'm gotta imagine that's a liter, 2 liter or something, I don't know. But the fact that it's a can is weird, so we're just gonna ignore the realistic aspect of this one. So the fact that it says it holds 40 cubic inches means that that's gonna be my secondary equation because I've got a number associated with volume. So then I wrote out the volume formula for a cylinder equal to 40. And it wants us to use the least amount of aluminum. So it would be cheaper to make the cans. And so from that front, surface areas, it would be the actual aluminum used to make the can. So we want to minimize surface area. Surface area is the area at the top and the bottom, and then like the soup label. Is that how your teacher probably explained it? I know that's how I explained it in Algebra 2, but I'm sure geometry is where you first learned it. So you unwrap the cylinder, it would be the circumference of the circle times the height, like a rectangle. So I usually explain it as a soup label. That's 2 pi r squared plus 2 pi r h. The equations look horrible, in fairness. So, out of the choices over here, it's far easier to solve for h than it would be to solve for r, because r you'd have to square root. So, it actually worked out okay over here because h was only in one spot. So with the substituting and simplifying down, it came out okay. It's not like it's an easy equation, but it came out okay. And then I needed to do the derivative of the surface area. Nice. Okay. Good. Derivative of the surface area, which again came out all right. So I got 4 pi r cubed minus 80 over r squared. And so then I would look for undefined and zeros. An undefined value at 0 was kind of worthless because I can't have a radius of 0. So I ended up finding 1.8534 to be the only actual critical number I could use. And then on the bottom, I had to find out and test. Oh, I forgot to write my other test number. I tested 1 and 10. So I tested 1 and 10 to make my number line. Technically, it's not like unbounded. I mean, like, in theory, the radius could be however big you want, because the height would just get shorter and smaller to compensate for that, but you know, that would never actually be practical. So I made it unbounded because it technically is, but it's just like the box problem. You wouldn't have a certain, no, not the box problem, the fence problem. You wouldn't have a fence that's like 20 miles long by 3 inches wide. So I proved that number was a minimum value. plugged it back into the substituted secondary one, and I got both dimensions. The horrible part of the problem is pretty much just the numbers. You needed a calculator. You're going to need a calculator when we get to these on the test, most likely, unless we really set it up so the numbers work out nice and easy. We don't usually like doing that on these problems though, because if the numbers work out that easy, a lot of people just try to figure them out in their head and then write the answer without doing any work. So I don't know, while it's up there, and I know you guys already have the filled out notes, like I always post the filled out notes, but I also know the person that writes those notes usually tries to skip quite a few steps in between. So I thought I would try to explain this one first. Anything somebody's looking at up there that's not making sense why I wrote it or where it came from, you know, like the goal here is that you would be able to try to do this process on your own.
The derivative for the blue one, you have 2 pi r squared plus 2 pi r h, and then you put the,
40 over pi r squared I put in place of h.
oh, I see.
So I got rid of h and then kind of, I wrote it as one instead of like a separate thing almost.
Thank you.
Yeah. He got confused where I wrote the second surface area equation from. You ever have the Chromebooks and laptops open? Put them away. Quit trying to pretend like you're going to multitask really nicely. Multitasking is the stupidest idea ever. It doesn't work. Multitasking just means you're going to do multiple tasks at a garbage level. Okay, let's do the second problem together. This one I wanted to do because it most definitely doesn't look like any one we've had. I'm pretty sure there's one like that in the homework, because I feel like some people have come to ask me about it. It's actually not bad once you realize what you're supposed to do. It also says a calculator question. I don't think we actually need one. So we're trying to figure out what points would be closest on that parabola to 0, 2. My initial guess would be like here-ish. That's going to be my guess. Like, obviously symmetrical, so it'd be on either side. It's definitely not 4, 0, because that's 2 squares away, and even if I just went horizontal, that's less than 2 squares away. So it's probably somewhere in between there, is my guess. Okay. The primary equation, there's very few words in this problem. That's where some people get really thrown off. The primary equation is going to be just this word closest. We are trying to have the smallest distance, or minimize the distance. So I'm going to look for distance minimum. And on a graph, yeah.
When we're like doing these problems, does it matter what we call it? Like if we just
Nope.
say minimum, that doesn't.
Not at all. You can call it whatever you want. I just wrote minimum and maximum before, but I was finding some people are getting confused as to what was minimum or maximum, so that's the only reason why I thought I would try that. Okay, so distance formula on a coordinate plane is distance between 2 points. So I've got x2 minus x1, which I'm not trying to find the distance between 2 generic points. I'm trying to find the distance between 0, 2, and 1 generic point. So I can actually write in some numbers right away. So I would have x minus 0, and then I would have y minus 2. If you wanted to do x2, x1, and then fill them in afterwards, go for it. Now the secondary equation is actually like uber obvious, but it's like so obvious that some people end up missing it. The secondary equation is literally just this. This is telling you how to exchange x and y. Y is the same thing as 4 minus x squared.
Can you turn your screen?
Yep, sorry, I forgot about that. So x squared plus 2 minus x squared. If you want to simplify it more than that, you could. It's kind of just up to you. Now, here's where I'm going to make it slightly easier on you. Don't write this part down. I'm going to erase it. So this is kind of the idea we're going from. Our whole goal is to minimize the distance, which is the square root. And the only way your square root is going to be the smallest answer is if the information on the inside of the square root is the smallest. So we're going to ignore the square root for the rest of the problem, because that square root will make our derivative way harder than it needs to be. And our goal is to find the smallest distance answer. And so we want to minimize the, I forget what they call the inside, the radicate? No. Radicate? I don't know, it's got a word for just the inside of the square root. Discriminant. I feel like it's discriminant. Doesn't really matter though. So we are going to look at the inside. I can't even spell inside. So we're going to make it easier on ourselves, and on the AP test you are allowed to do this too. You would just need to write a sentence explaining that fact, basically what I wrote at the bottom. So if you reason and explain it, that looking at the square root is kind of worthless for this one, then that's fine. So now we'll do the derivative. So the inside derivative would be 2x plus 2 minus x squared to the first times negative 2x. So what do I have? What is that? Negative 8x, and then plus 4x squared cubed, 4x cubed. I don't know if I went through this part too fast or not. How are you guys feeling about this part? Okay. You basically I started off by writing out the distance because I knew that's what needed to be minimized or maximized. Then I found the secondary information that was going to help me substitute things. And then I simplified it. And then our goal from there is to do the derivative so that we can find critical numbers, which will automatically be the maximum or minimum information. Now, let's see, who has not been called on for? Brooke hasn't been called on for a long time. Are you ready?
Sure.
Okay. We don't want Donald to die either. You okay?
Yep.
Okay. What do I do from here? Like, I found the derivatives. Yeah, that's pretty much what most people say when they're doing their homework. What have we done about 1 billion times with our
I'm
derivative?
gonna say you try setting it equal to 0.
That's perfect. Even if you're not sure why, just do it. Like, if you're taking a test and you're lost, go by what we've done 1 billion times at this point. We derivative. We make things equal to 0. Like, if you're completely lost, just do things we've done a lot of. Okay, so this one has no undefines. Oops, I'll actually just factor it. I'm kind of running out of space. 2x times 2x squared minus 3 equal to 0. So these are critical numbers. They guarantee where it's the maximum. Get off your phone, for crying out loud. You sit on your laptop, you take out your phone.
Sorry. I still didn't get on the test though. So it works out for me.
Now what though? Oliver? Okay, we actually didn't even find critical numbers yet, but I set it up for it. Do you want, I can write them out. Now what?
I'll make a number line.
Oh, okay, good. Our number line, 100% can be any number. Like this one, they're positives and negatives, they're all allowed. So our number line is 100% going to have all 3 critical numbers. I'm sure this one says calculator because of the square root of 3 halves. However, I feel like you guys should be okay with square root of 3 halves. Square root of 1 is 1. Square root of 2 is 1.4. So we know that this number is in between 1 and 1.4. And if you don't know square root of 2 is 1.4, you should. Square root of 3 is 1.7. These are numbers you run into all the time, so you, like, lots of classes. So, Andrew? Wait. I'm trying to remember how I'm supposed to say it. You let me say your name wrong for so long, I can't remember. For Bob.
Yeah.
Who's on his Chromebook for some reason.
No reason.
He's a much worse liar than you.
I'm not lying. I'm
Just had to have it open. What do I do now?
Find where it's increasing and decreasing.
Okay, how do I do that, but you are correct?
Substitute x is equal to 0 and x is equal to plus minus root 3 by 2 into the original function.
So you're trying to tell me to find critical points right away?
Yeah.
Not a bad idea. But that won't help me in terms of increasing, decreasing. But I can put 0 and plus and minus square root of 3 over 2 on my picture. And obviously I think 0 is not going to be the answer. I think it's going to be those two, but I have to prove it. I'll do the points at the end. How do I figure out if it's going up or down?
Substitute it into the derivative function. Like substitute numbers before and after into the derivative.
Okay, what number would I pick over here? that would work. 'Cause that'd be the square root of 4, so that would work. So I'm gonna put 2 into here, whichever one you want. 4 times 8 is 32, minus 12 would be 20. That would be positive. I 100% did it wrong, is what you're saying? I like how you guys finally fact-checked me right away. You're right, I did regular 2, didn't I? Well, I can write that answer over. So here, right, negative 2 cubed would be negative 8, so negative 32 minus, which would actually be plus 12,
Minus 20.
negative 20. Negative 1 would work, because that'd be the square root of 1. Is this plus?
Isn't like root 1.5 less than 1?
No. Root of point, maybe you're thinking 0.5.
Yeah, I guess that.
So 1.5
Just up
would be in between 1 and 2. I'm assuming plus, minus?
Yeah.
You guys already do them?
Yeah.
Okay, thanks. All right. No, we called on Owen yesterday. Mila, you did not get called on yesterday. I know, which is why I called on Brooke as well. So what do I do with that information? Okay. Down, up, down, up. Minimums would be. Perfect. These would both be, I mean, they're relative minimums, but they're also absolute minimums because it's going up everywhere else. So it's relative minimums is the method we used, but it is absolute minimums. And so plus and minus square root of 3 over 2. And now I just have to find their y values, which if I remember right, wasn't horrible. But I could be wrong. I need to plug it in here. Yeah, because I'm squaring it, so it's not too bad. So 4 minus a half would be 2 1/2, so 5/2. And actually, the point that I drew on there is awfully close. 5/2 is 2 1/2. So those are the points that are the closest to 0, 2. What you'll find with these is these are easy to start. The answers usually get terrible. The work involved in the closest distance problems isn't bad. It's always usually going to be the answers. Okay. Wait, did we go to 27? Did I go that fast?
Yep.
Huh. Did I skip something that I was thinking of? Whatever. Okay, well, I guess you guys won't argue to having work time here. Yeah, I was thinking this would take us like the whole hour. What did I do? Maybe I just didn't call on you guys nearly enough. Maybe I just answered too much on my own. Okay, well, do you guys want me to explain something up here that I wrote that you don't know where it came from, anything like that?
Just the initial
Distance formula between 2 points? I chose distance between 2 points because the graph itself is coordinate points. So the distance formula is x2 minus x1 squared plus y2 minus y1 squared equals distance squared. So we theoretically could have chosen distance squared and not used the square root symbol as well. But I didn't do that because I didn't know if it would confuse you guys when I did the derivative of distance squared, and I would have ignored the square. So I kind of chose the square root version. Okay.